be a symmetrical bell-shaped on either side of it, sort of a ski slope going down from the peak.
All right.
So that was their discovery, and that's what Planck did and tried to reduce it to equations. But he was essentially forbidden to use Abraham de Moivre's formula, so he never worked it up properly.
All right. So, but then if you change some of the other variables, let's say, like in Edison's case, I think he wound up with a tungsten filament, and that was the thing that worked best. So if you have like a different material as your light source, a heat and light source, increasing the energy might have a radically different result, correct?
To my knowledge, you always get a bell-shaped distribution, but the location, the frequency that it sits on, the centermost frequency is different. For example, if you take a little bit of table salt and you put it in a flame, a Bunsen burner flame, the flame goes very brilliantly yellow.
Mm-hmm.
And that's typical. Sodium is comfortable at that, whatever frequency is yellow, that's the frequency that sodium likes.
Yes.
And if you take other elements off the periodic table, they will also show particular colors. If they're reacting in the visual range, they'll show a frequency as characteristic. So in other words, you always get a population distribution, but where the brightest frequency is located is different with where you are on what element you pick off the periodic chart.
Okay. All right. Okay. So, well, let me change the subject because you brought up an interesting fact, a factoid about de Moivre being banished from the scientific community. And I have been arguing for many years now that the Jews have been manipulating the science of linguistics, and they have falsely categorized Hebrew as a non-Aryan language when I know very well it is an Aryan language. Okay, it's directly related to Welsh. I think it was Tyndale who said that in order to translate Hebrew to English, he doesn't have to even worry about syntax. He simply replaces the Hebrew words with English words, and it makes perfect sense. Okay, and the reason why the Jews have created this false idea is because they want to claim that they're Semites and the Aryans are non-Semites, of course, but the reality is that the Aryans and the Semites are the same people. The Jews are the ones who are phonies. They're not Israelites, Semites, or Judahites, or Israelites at all. They're, in fact, Canaanites, and therefore they have manipulated the whole field of linguistics to pressure people to continue this lie. And so now you're saying that they have done likewise with this French physicist de Moivre to try to put an end to his theory.
Just what you said is even more true. Right now we're in a battle between people who do geometry, like me, like Joel Mayer, and people who want to do just algebra, like Jews. Now, what I dislike about the Hebrew alphabet is it's all consonants, and it's very harsh.
Yes.
And a Jew goes into a rapture when he can do algebra. He's repeating his Hebrew Sunday school because he just throws consonants on the blackboard. They don't mean anything, but it looks Jewish to him, so he's happy.
Yes, yes. And he can fill in whatever vowels he wants and make it mean what he wants.
Yes, but see, the thing of it is that algebra was invented as a substitution for geometry because the geometrical diagrams became too difficult and too cumbersome to draw on the blackboard.
I see.
So algebra is not a higher level of mathematics.
No.
It's a crude form of it's like being a courtroom stenographer, essentially. That would be the best analogy. So you're perfectly right. What you said, I understand what you're saying in your particular arena, which is spiritual things and linguistics and humanism, but they're doing it in algebra. They're taking the cross for multiplication. That's being replaced with a little asterisk. I'm serious.
Yes.
I've gone through several versions of a software package that's a Jew thing from Mathematica, and they've taken out the cross, and they use the asterisk now for multiplication or a blank space.
Yes.
Because they see an X as having it's a Christian symbol, and they're throwing it out.
Yes, fascinating. Just as they're doing in historical research, where they pressure people not to use BC and AD, and they have substituted BCE, which means before the Common Era, and I forget what the other one is for the current era. because BC means before Christ, and AD means Anno Domini, the year of our Lord. And so, exactly, they're trying to take over. They're trying to expunge the memory of Jesus Christ by instituting these new traditions in mathematics, history, and religion.
Yes, exactly.
Absolutely fascinating. Here, I want to get into real briefly. I mean, our discussion has been tremendous so far, but I want to discuss briefly the fact that Einstein was not a mathematical genius, as is commonly, portrayed. This is from the Tesla Memorial Society of New York. And by the way, Nikola Tesla was probably the most brilliant scientist who ever lived. My understanding, he just saw schematics in his mind and was able to build things where just within a few days or weeks, whereas Edison would take years to do what Tesla could do virtually instantaneously. But Einstein married a Hungarian woman whose name was Mileva Marek. Okay, Mileva Marek was Albert Einstein's first wife. Einstein married Mileva Marek on January 6, 1903. The two witnesses at the quiet wedding were the original members of the Olympia Academy, Maurer, Solovine, and Conrad Habecht. There was no honeymoon, and after the celebratory meal in a local restaurant, the couple returned to their new home on 49 Kramgasse, close to Bern's famous clock tower. They had two sons, a Serbian, their daughter, Lizerl, was born before their marriage and died in childhood. At the time of Mileva's death in 1948, her oldest son, Hans Albert, was a professor in hydraulic engineering at the University of California at Berkeley. A Serbian mathematician, Mileva Marek was Einstein's companion, colleague, and confidant, whose influence in his most creative years was enormous. After their marriage, Mileva subordinates her professional goals to Einstein. She was born, the text is cut off here, a northern part of Yugoslavia of Serbian parents. Einstein and Mileva met as students at the Swiss Federal Polytechnic Institute in Zurich. At the age of 21, Mileva entered the Swiss Federal Polytechnic in 1896, the same year as Einstein, who was 3.5 years younger than Mileva. She was in that year the only woman beginning studies in the mathematical section of the School for Mathematics and Science Teachers. The long and short of it is here, this article argues that Mileva was the mathematical genius and that Einstein had to depend on her for all of this early math. Now, of course, everybody knows that Einstein worked in the patent office. Is it not conceivable that Einstein did not create these ideas, but simply plagiarized them from being in a position at the patent office to steal these ideas from people?
Okay, there actually is. I can confirm your suspicion completely, and
okay.
I'll give you a reference for that. You can get this book as a downloadable PDF. There was a man named Whittaker. His initials are E.T. And the title of his book, this is a book he published in 1910 called A History of the Theories of Ether and Electricity.
Okay.
Now, the PDF, the first edition, is available through googlebooks.com. You can download it as a PDF, and he actually says, he comes right out and says that Poincare and Lorentz had more to do with the theory of relativity, but Einstein was Einstein looked the way that people were ready to perceive a Jew. Mm-hmm. In other words, he was a bridge figure. It went from Charlie Chaplin to Albert Einstein to Woody Allen and to Bob Dylan. You see what I'm saying?
Yes.
They had the same kind of a sort of an Ashkenazi, little bit of Sephardi, but more Ashkenazi, like you could sort of trust him. So it's sort of like you have the Marx Brothers on one end of the spectrum,
yes,
and then you have Einstein on the other, who looks like a foolish floppy genius, and that's the whole thing. He was somebody you could sell. He had the kind of photogenicity. He was photogenic. But Whittaker's book actually says, word for word, what you just said, that Poincare and Lorentz had more to do with the real the valuable side to relativity theory.
Okay. Well, let's go into this whole discussion now of relativity. Can you give us like a quick character sketch of the transition first from Newtonian mechanics to relativity theory, and the Lorentz transformations and what those are all about.
Okay, well, the idea of classical mechanics, the idea that everything is a body, Newton went to his grave thinking that.
Okay.
And he thought that light would have to be particles.
Really? Okay.
And everybody said that the people who were opposed to him said, well, Isaac, how could a particle move in outer space between the sun and the planet Earth where it's absolute vacuum?
Mm-hmm.
And as a result of that, this magical substance called the ether was invented.
Okay.
And the ether is supposed to be like a liquid medium.
Mm-hmm.
So just picture a wave. Just picture a wave on the surface of the ocean,
sure.
And that's all the ether is. It's just a medium that is required to transmit a wave.
Right.
And
right.
Newton was tongue-tied because he didn't think like I did of the cycloid. And the cycloid, again, the cycloid curves were they're a family of curves that were very popular with certain Christian scientists that the Jews looked down their noses on.
Okay.
So they never got it. They never got anywhere. They were sort of like they were cut off at the pass.
All right. What is a cycloid? It's an energy field, correct? Some kind of energy field? No.
No. A cycloid is a particular kind of curve that you get by combining two distinct motions.
Okay.
Okay. Now I'll give you the easiest example. You take a bicycle wheel take it off the bike and roll it on the blackboard, on the chalk rim on a blackboard.
Mm-hmm. Okay.
And you hold a piece of chalk against the tire of the rim as the outer edge of the tire as you're rolling the wheel from left to right, so you're walking from left to right in front of the students, and you have the piece of chalk scraping on the board.
Right.
The board, the arc that is drawn by that, the combination of motions is the chalk is moving from left to right, but it's also moving in a circle at the same time. It's moving in a circle.
So I'm picturing, as you're saying, the result of that drawing, if the chalk stops at the bottom of the chalkboard, it would be something like a bunch of half curves pointing downward at each point where it stops at the bottom of the blackboard. Something like that? Is that a cycloid?
But wait, now that's where now we're getting into the issue of a little knowledge is a dangerous thing.
Okay.
You're right. The common cycloid comes to a halt abruptly when you reach the bottom of the chalkboard.
Okay.
It's very difficult to see how that could be confused for a sine wave.
Yes.
But the cycloids as a family are what they call they're made out of parametric equations. The parameters can be adjusted so you get an up and down vibration. Now, is there any chance you printed out anything that I sent you?
Well, yeah, I got your talking points, but I didn't print out the full article.
Okay, because if you would look, the proposal that I sent to the National Aeronautics and Space Administration, if you look on page 5, you can see the actual differences between a cycloid and a sine function.
Okay.
A sine function goes above and below the x-axis.
That's right.
In a perfectly symmetrical fashion because it's dependent on a medium, and the medium is elastic in all three dimensions in an identical fashion.
Mm-hmm. Yeah, so it's a very smooth function going up and down across the median line, and like a wave going across the ocean.
Now think magnets. Now think a magnetic field, or think of heat. If your hand is real close to a candle, then you're going to feel the heat.
Yes.
And the further away you go, then there's less heat. So that's a field. That's a caloric field. That's a hot and cold field.
Yes.
And then you have an electric field, which is just think of like a Jacob's ladder.
Okay.
Think of the spark jumping across the peaks at a Jacob's ladder.
Okay.
So you have three separate fields. Those fields, if they're combined with the right geometry, they will give you an up and down motion for the electrons.
Mm-hmm.
And it turns out that the motion, the intensity of the magnetic field can be weak. When it's weakest, that's when you get the up and down motion.
Okay.
And when you raise the intensity of the field, then you're talking about the behavior in particle accelerators, and you get the prolate cycloid, which is what I curve fit to Kaufman's particle accelerator. So the skepticism in your voice is because you kind of glommed on to the cycloid. That makes sense.
Yeah.
But no one ever told you about the variance on the cycloid. But there are actually about 60 variants on the arc of the cycloid.
Okay.
60.
All right, quick question. How does this influence our concept of waves and particles? Because we understand, that the universe is composed of waves and particles. How does this cycloid impact our perception of those two things?
Okay, now